Hi, everybody. This is Charles Hoskinson broadcasting live from warm, sunny, Corona-filled Colorado. This is the video I actually wanted to make. The last two videos were event-driven videos, one about the markets and the other one about recent losses in the family. But this video is a celebratory video, and it's a video to talk about some major accomplishments that the research team has finished. So many of you may be aware of the research agenda that we followed from 2015 on. The Cardano project sought to really deeply investigate how to make proof of stake practical and work well for everybody. So really this required us to take a look at the entire science of proof of stake, the entire science of consensus protocols for our industry. And what we needed to do was come up with a practical solution that would allow us to gradually scale as we gained users. So as the system got more decentralized, the system would perform at the same rate, or it would get faster like BitTorrent does. So this was an extraordinary ask because there were so many other considerations: adaptive security, semi-synchrony. We wanted fast finality. We wanted the ability to bootstrap from Genesis without having a checkpoint. We wanted to decouple the clock. We wanted to be able to recover from spikes of dishonest majority. And also we needed to build a delegation system. We needed to build a stake pool system. And then we needed a productive way of orchestrating, curating all of that, including building a brand new way of handling networking for our entire industry. So this together was a colossal task. And it's something that has consumed now 5 years of research by a team of more than 24 scientists and engineers working basically full time since we started it. And it has resulted in over 1,000 citations and basically a whole corpus of knowledge, enough to write a monograph. The capstone of this entire research agenda is Ouroboros Hydra. And we finished the initial build of that paper in November. We submitted the conference build February 15th to Usenix, and we have submitted it, and it has now today been posted on ePrint, meaning for the first time ever, and it's in the link of this tweet, the Hydra paper is publicly accessible. It's really a marvel of engineering. It's an isomorphic state channel paper, so it's a layer 2 solution that can sit gracefully on top of the Cardano protocol and accelerate it. And it's something that fits very nicely with our stake pool model. Simulations show that each Hydra head can perform at the moment around 1,000 transactions per second, and there's a lot of room for optimization of that. Furthermore, we have a lot of evidence to show that as we add heads to the protocol, we should get reasonable scaling, meaning that it's around linear scaling. Obviously, you can't get perfect linear scaling due to a lot of overhead and things like that, but it's close to linear is our belief. And this model fits extremely well with the extended UTXO model because we have natural ways to shard the stake space without sharding the ledger itself. So what this effectively means is that if stake pools were to create heads, each stake pool, for example, could have a head, then as we add more stake pools, we get more heads, and the performance will scale up. So for example, if you have 1,000 TPS and 1,000 heads, you could be looking at a maximum theoretical performance of 1,000,000 transactions per second. And these heads could do things, for example, like fast finality. So things can clear instantly, just like they do in a traditional BFT protocol. And these heads allow for microtransactions, micro payments, so micro tipping, small things like that. In addition, we get to benefit from years of research in state channels and payment channels for routing and interoperability. So we're super excited to bring this paper to market. It's actually the first interdisciplinary paper where we had network people, MPC people, programming language people, and consensus people working together to figure out the theory. And we're so excited that the smart contracts that can run on the base layer, we have shown are isomorphic with what can run in the state channels, meaning that if you have a Plutus smart contract in our model, it's going to be able to run in that head one for one. This is not a trivial thing to show, and it's not a trivial thing to do, but it's super exciting to show that that's indeed possible. So there's a lot of cleanup that needs to be done, and there's some prototyping and implementation that needs to be done. But what is most exciting about this is that it can be implemented in parallel with all of our work on Shelley, Goguen, and Voltaire. You see, because this is a solution that plugs on top of our model, probably adopted first by the stake pools, we can have an independent team similar to the team that we have with the incentivized testnet and other things to work exclusively on this Basho site scaling. So that's super exciting. Second, this solution is complementary to ledger-based sharding solutions that we're seeing in industry. So the plan for the main team will be to implement all of the Shelley and Gilgan features and continue to upgrade the network stack. And we think the max theoretical performance unsharded on the base ledger will look around 1,000 transactions per second at the base ledger. And then each stake pool, for example, can run heads, and each of those heads can add an extra potentially up to 1,000 TPS in the current design, according to simulations you'll see in the paper. And then basically, as you add heads, you get more performance. And so when you look at the dynamics of a system like this, we're Visa scale at the base ledger and comparable with our fastest competitor, Ripple. And then at the head level, we can scale to a global system that is very natural and easy to shard. And those heads can also be used for interoperability with other networks like the Bitcoin network, the Lightning network, and so forth. And it'll be very easy for us to eventually layer a payment system on top, as well as a decentralized exchange mechanism on top of that. So to get to this capstone where we saw our language group be able to prove nice isomorphic properties, to see our extended UTXO model demonstrate that we can successfully shard that space, and it's easy for us to segregate these things, to see the theory of consensus and the theory of Ouroboros mature to a point where we have comparable properties with Bitcoin, from recovering from dishonest majority to bootstrapping from Genesis to operating in a semi-synchronous environment to adaptive security. This is really a major scientific milestone for the industry as a whole. And so we're incredibly proud to publish this paper. It's really a bittersweet moment because the first research line, that whole 5 years of effort, is starting to kind of come to an end. There's not much more to publish there. There's certainly a lot more to optimize. There's harder problems to work on moving forward. But basically, we solved the problems we set out to solve for Cardano, to make Cardano truly a scalable system and to bring Cardano into the future. And now the hard task of translating that science into real code and bringing that into the system has begun. The lucky part is that there's an enormous amount of body of work that has been done thanks to Lightning and thanks to state channel research that allows us to bring these solutions in rapidly. And we won't start from zero in that respect. And also, we can now engage a parallel team to start that implementation work in tandem with the Shelley and Gilgan work. One of these things pull together, Cardano truly will be the fastest system in the world, and also contain all the capabilities of our competitors, from fast finality to micropayment friendly to easy interoperability and other such things. So thank you all for your patience in waiting for this paper to come out. It was very difficult for us to translate the one we submitted to conference to the one that we submitted on ePrint, because I believe the page limit was 18 pages for the conference submission, and this paper came in at 55. So it was a very significant editing process to get the paper to where it needed to go to be publicly accessible. But now it's finally in your hands, the consumer. So do read it, do play around with it, and do let us know what you guys think about it. And the product manager who will begin regularly updating you guys in short order is Rob Cohen. So after we finish some remaining work on the launch of Shelley and cleaning up the Shelley node, Rob is going to fork off, and he will work full-time with a full implementation team specifically on building Hydra and bringing Hydra in. And you will see monthly updates from Rob as you see the monthly updates from Aparna and Nick and the other product managers in the queue. So that's a first-class citizen, along with Voltaire and Gilgan and the rest of the gang. So look for that in the coming months. And thank you all so much for playing around with it. And we look forward, and we're super excited to adding this as another value proposition and revenue generator for stake pool operators. And we look really excited to adding this solution in for accelerating Cardano and taking us to the next generation and the next level. This is the dawn of the Basho era in this respect. And it's nice to see the light at the end of the tunnel for the entire roadmap. So let me know what you guys think about the paper, and happy reading. Cheers.